Howdy, my name is Breck, and for my end of semester project, I'll be teaching you how to create a basic Lewis dot structure. Anyways, let's begin. For this video, we are going to be creating the Lewis dot structure for carbon tetrachloride. Look at the periodic table. Count the number of spaces from left of the table along the period to find the number of valence electrons of an element. As you can see, carbon has 4 valence electrons, and chlorine has 7. Remember, transition metals do not factor into this count. Add all of your valence electrons to get the total valence electron. In this case, the total is 32. Check the electronegativity for each element in your compound. As you can see, carbon has an electronegative charge of 2.55, and chlorine has an electronegative charge of 3.16. Situate your element so that the element with the least electronegative charge is placed in the center. Surround the remaining elements around the central atom. The octet rule states that, except for a few exceptions, all atoms must be filled with exactly 8 electrons. Connect bonds to each of your atoms with a line. Each connection is worth 2 electrons. Fill the rest of the atoms with lone pairs. Lone pairs are 2 dots on different corners of an atom, with each dot representing 1 electron. Notice how carbon has 4 bonds, totaling 8 electrons. Chlorine has 1 bond and 3 lone pairs, also totaling 8 electrons. Now let's check our final structure to see if all the rules are followed. Remember that we have a total of 32 electrons in this compound. Taking 4 bonds into account, we can subtract 8 electrons, giving us 24 remaining. Each chlorine atom has 6 lone electrons. Notice that if we take the 4 chlorine atoms into account, we have 0 remaining electrons in this system. This indicates that our Lewis dot structure is complete.